Okay, so this is lesson 11.4, where we're talking about rotations, which used to be called a turn. So a rotation, or turn, is a transformation in which a figure is rotated about a point, and that point is called the center of rotation. We'll be using the origin of the coordinate plane as our center of rotation. The number of degrees a figure rotates is the angle of rotation. In a rotation, the original figure and its image are congruent. In example 1, identifying a rotation. You must rotate the puzzle piece 270 degrees clockwise. Remember, clockwise is the way the minutes, the hours, and the second hands go on a clock. So clockwise about point P to fit into a puzzle. Which piece fits in the puzzle as shown? So the study tip says, when rotating figures, it may help to sketch the rotation in several steps, as shown in example 1. So notice they rotated it 90, then another 90 to be 180, and then a third 90 to finally be 270. I recommend, if you have some wax paper at home, usually that's thin enough where you can see through it. Then you put that over the figure, you trace the figure on the wax paper, you put your pencil point down right on the origin, which you can see through the wax paper, and then you can rotate the wax paper around the origin, and either clockwise or counterclockwise, however many degrees you want to. That will help you to see where the new image is going to go. Then, of course, you would sketch it in. So here are some problems to do on your own. On your own 1 and on your own 2. Example 2, rotating a figure. It says the vertices of a trapezoid are -4, 2, -3, 4, -1, 4, and -1, 2. Rotate the trapezoid 180 degrees about the origin. What are the coordinates of the new image? Now, here's what I would recommend. You have graph paper, you plot the points, you draw the original figure. Then you put your wax paper over it, and you trace that figure onto your wax paper. Make sure when you trace it on there, you do label X, Y, Z, and W for your points. Then you put your pencil down at the origin, and you rotate that wax paper 180 degrees. Then you'll see exactly where these points are supposed to go in the coordinate plane. You can see where Z prime would go in place of Z, W prime would go, X prime would go, and Z prime would go. Then you kind of have to lift the wax paper up and plot those points. Then you can redraw it in there and find the coordinates of the new image. Example 3 is another rotating a figure, and actually this is one where we're not rotating around the origin. But if you take your graph paper, you plot the points J, K, and L, and you draw in your triangle, and then you put that wax paper down on top of that, sketch in J, K, L on your wax paper, and then here you're going to rotate it about the vertex L. So you'll put your pencil point down on L, and you will rotate the paper 90 degrees counterclockwise. Once you do that, you'll be able to see where the new image is going to show up on your coordinate plane. Plot those in. Since we rotated about L, L isn't going to move, so that'll stay the same. But J and K will both rotate counterclockwise. You'll sketch them in, and you'll get the new coordinates. Using some kind of transparent paper makes this a whole lot easier than trying to visualize what's happening. For example 4, we're doing more than one transformation. So here, the vertices of the rectangle are given, and you're supposed to rotate the rectangle 90 degrees clockwise about the origin. Once you've done that, then you're supposed to reflect it in the y-axis and get the new coordinates. So when you do that, The first transformation will give you your first image, and we'll label those A prime, B prime, C prime, and D prime. And then the next transformation will give us A double prime, B double prime, C double prime, and D double prime. And you can see it's notated with 2 tick marks up there instead of just 1 tick mark. And then you get the coordinates of the new image. Take your time, make sure you're accurate, because any mistake here is just going to continue a mistake throughout the rest of the problem. Here in example 5, we're describing a sequence of transformations. It says the red figure is congruent to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red. So the red was the original. So they gave us one example. You can turn the red figure 90 degrees so that it has the same orientation as the blue figure. Then you can slide the figure up, and you would have to slide it 4 units up if your rotation was a 90-degree counterclockwise rotation about the origin. So there are some for you to do on your own. Number 4 is just a sequence of transformations, and number 5 is describing a different sequence. There will be multiple answers, but do your best. I know you can come up with one or 2.